Hi, and welcome to 8.1 Systems of Linear Equations in Two Variables. So, what a system of equations in two variables looks like essentially is this. A system meaning we have more than one equation, and two variables meaning that each of these equations have two variables. So, any solution that satisfies both equations simultaneously is a solution to the system. So, if we think about this really quickly, we can look at these individually. If we have y minus x equals 1, we can think about what the graph of this looks like. And if we add x to both sides, we get y equals x plus 1. We know this is in slope-intercept form, and that's y-intercept 0, 1, slope 1, so we get up 1 and over 1, and that's the line. So any point on this line is a solution to this, so any point on this line is said to satisfy that equation. Now if we look at the second line here, x plus y equals 3, subtract x from both sides, and we get y equals negative x plus 3. This is in slope-intercept form, so we plot our y-intercept 0, 3. And the slope being negative 1 means go down 1 and over 1, and we draw the line that goes through this. Now, any point that's on this line is a solution to this equation or said to satisfy it. So if we're trying to find the point that makes this equation true and this equation true, it's going to be the intersection point, which is this point right here, which if I drew the graph a little bit better, we would notice is the ordered pair 1, 2. Now, there is a way we can check this, and it's by plugging that back into these original equations. Now, if I plug this into the first one, y minus x equals 1, we have 2 minus 1 equals 1. That's true. If we plug this into the second equation, x plus y equals 3, we get 1 plus 2 equals 3. That's true. So this satisfies both these equations, and this is the solution to this system of linear equations. Okay, so that's what we're talking about. Satisfying both equations means it's an ordered pair that makes both of those things true simultaneously. So there's a couple different possible ways that we can have two lines live in the plane. That is, these two lines right here are parallel, and if the solution to these systems is where those two lines cross, since these two lines do not cross, this is said to have no solutions. Anytime we have no solutions, that is said to be an inconsistent system. So notice, an inconsistent system, the system has no solutions. Another way two lines can meet in the plane is like this right here, where they touch at one spot. This has one solution. Anytime you have a solution, the system is said to be consistent. So this is a consistent system. Now this one over here, the two lines lay on top of each other. That is, one of the lines is there and one of the lines is laying on top of that. So when the lines lay on top of each other, there's an infinite number of solutions. That is, any ordered pair that makes this line true, makes both lines true, there's an infinite number of solutions. Now, because there's at least one solution, this is said to be consistent. Now we get into dependent and independent. Two lines are independent if they're different lines. So this is independent, these are two different lines. This is independent, these are two different lines. When they're the same line, the two lines are said to be dependent. So that's a little bit of terminology that we want to take a look at. So what we're going to be doing is solving and classifying these systems, and that's kind of what we're going to be doing from here on out. So we're going to be using a graphic approach. There are algebraic approaches that we're going to explore in the second and third section, and that's primarily what we're going to be doing, but there is this nice geometric interpretation of what's going on, so let's just take a look at that. So in this first one right here, we have 2x plus y equals 6. So if we want to graph this, 2x plus y equals 6, I'm not going to solve for y, I'll just go ahead and find the intercepts. Once again, if I'm finding the y-intercept, I plug 0 in for x. So let me get this a little bit shorter, we probably don't need that much. So I have a plug 0 in for x, we have 2 times 0 plus y equals 6. 2 times 0 goes away, so we get y equals 6. So 0, 6. That is a point on this line. Now to get the x-intercept, we plug 0 in for y. So plugging it back into this original equation, 2x plus 0 equals 6. That goes away, divide both sides by 2. We get x equals 3. So 3, 0. Okay, so those 2 points uniquely determine a line, and it's really kind of important to try to draw your line as best as you can so you can really get an idea as to where these two lines are going to intersect. That's going to be important. So I'm going to try to draw this as straight as I can. Okay, that looks pretty straight to me. So now let's go ahead and graph the second. Well, the second one here, I'm going to solve that for y, just to give you a little bit different flavor. So if I subtract 3x from both sides, we get cancellation here, so we get 4y equals negative 3x plus 4. Divide everything by 4. These cancel, so we get y equals negative 3/4 x plus 1. Okay, so we have our y-intercept at 1. We go down 3, 1, 2, 3, and over 4. Okay, so then draw the line that goes through these 2 points right here. And it looks like these two lines intersect right about here. So it looks like the ordered pair 4, negative 2. So there's a way we can check this, and we can check this by plugging it back into these original equations right here. So first I'm going to plug it into the top one. That is plugging the x in for x. So 2 times our x, 4, plus our y, which is negative 2. That should equal 6. I'm plugging these values into this top equation here. 2 times 4 is 8, so we have 8 minus 2 equals 6. That makes that true. But we need to make sure this makes both of these true. So now I'm going to plug it into the second one. 3 times our x4 plus 4 times our negative 2 equals 4. Well, let's take a look. 3 times 4 is 12 minus 8 equals 4. Sure does. So what that tells us is that this right here is the solution to our system of linear equations. Now when we're classifying this, because there's a solution, it's said to be consistent. And because we have two different lines, these lines are said to be independent. So this system is consistent and independent, and that right there is the solution. So we'll see you for the next one.